back down to the ground. Now, I have, if I didn't erase it, here's the height formula. It's a quadratic in terms of t rather than x. We're good. Can anyone tell me, a little common sense, when it hits the ground, what up there on the board do you know has to happen? Now, I know it's going to hit the ground with some velocity. I'm not going to ask you what velocity does it hit the ground. That's physics. Can anyone tell me, though, what you see on the board right now has to be true, has to happen when that stone hits the ground? Something up here on the board has got to be true when it hits.
Oh, h will equal 0.
The height is 0. The height is 0. There's no height. So to answer Jonathan's question, how many seconds, Professor, will it take to hit the ground? I'm going to go back to this and replace h by 0. The entire height is 0. So h of t, all that's 0. And I got 0 is equal to now, he gave me this earlier. We've got this. That's what you're doing. When it hits the ground, that's the only thing I see true. The height's 0. There's no height. So set h equal to 0. Now solve this, guys. Now this is solving. Many ways to solve this. You can use quadratic formulas. You can try to put it in a factored form. Complete the square. I think most students would try to avoid completion of the square. That would work. Guys, I'm going to do mine by first. I think all those numbers can be divided by negative 16. That would help. So just divide both sides by negative 16 first. And guys, we'll end up with 0 is equal to t squared minus 3t. I think it's minus 2. Oh, that's much better. Let's divide everything by negative 16 to make it look better. Just so happens that will not factor. So now I must either complete the square on this thing or or use the quadratic formula. So I'm trying to find t, I'm going to use quadratic formula, guys. Negative b plus minus square root b squared, subtract 4 times a times c, and make sure I put my numbers in there correctly, replacements, and it looks like that. Clean this up. I've got a 3 out front, positive, plus minus. Now, underneath there, guys, what is that, Mona? This is looking more like what you were doing. What is all that underneath that square root? I think 17. I think it's 9 plus 8 on the end. All over 2. Strange answers. Because they're asking me how much time does it take after you release that stone for it to hit the ground. Well, we've got 2 answers here. So one of the answers to, or one of the numbers to recommend to look at is 3 plus radical 17 over 2. And the other one is 3 minus radical 17 over 2. I just separate them for the times. Those are the ones we're supposed to consider. Now, Jonathan, I know I got strange answers. I'm not going to ask you to approximate them. But I do know myself, square root 17 is not perfect. It's 4 point something. But square root 16 is 4. So it's 4 point something. So it's like 3 plus 4 point something is 7 point something. And divide that by 2, 7 point something divided by 2 must be 3 point something. Okay, so it's going to take over 3, seconds in this case, for it to hit the ground. Okay? So I'll accept that. I'll just leave it like that. I'm not going to ask you to approximate, but I think it is 3 point something, if I did the calculation correctly. Guys, this one down here, which is a consideration, must be ruled out. Why?
Time can't be negative.
Thank you, time cannot be negative, and I know right now, this says 3 subtract 4 point something. That's for square root 17, 4 point something. And 3 subtract 4 point something would take you into the negative number, and I cannot have time to be a negative. Okay, so the only answer, and the precise answer, the exact answer, is that many seconds it'll take for it to hit the ground. And we'll just leave it like that without an approximation. Oh, and remind me, I raced. How many seconds did it take for it to reach its maximum height?
1.5.
1.5. So it's gonna make sense now for it to now fall back down. It's gonna be a little bit over 3 seconds. That's true? Make a little sense there? So I'll accept this right here, reject this one, because it's negative. Mine.
If we start on the ground though, and then,
Oh, if you start at the ground now, this is on top of the building. So they're saying the time from your position on top of that building,
right,
okay?
but if we were on the
Oh.
ground, then we would just double the x of the vertex?
Oh, whoa, hold
Or
on.
it would
hold on.
take the same amount of time, right?
It might, look at that. Yeah, guys, suppose I'm on top of the building here, I'll erase this thing here. She said, Professor, suppose you're down here on the ground, and you toss the stone from ground level, you're not on that building. And you wanna follow the same, I guess, the same formula he gave you for the height.
I guess, is there a shorter way?
No,
Okay.
no. Okay, no. Okay, guys? Okay. Woo! Now, Jonathan, we have one more application. I'm holding responsible, guys, just for 2 types of applications on the exam on Friday. It could be a stone being tossed in the air. That's very easy. Now, the next one's gonna require a little bit more work. So I'm gonna do it. It's another application of a quadratic. Jonathan, if you don't mind, would you please read that to us?
Okay, so the second one is SMC is under construction. Workers have 1,200 feet of fencing to enclose a rectangular space that borders on Pico Boulevard. If no fencing is needed for the side along Pico, what is the largest area that can be enclosed?
Oh, my goodness, oh, my goodness. Yes, we definitely are under construction. Oh, you guys are here, you couldn't believe a couple of years ago, ooh, there's a mess around here. All these new buildings going up and old buildings torn down. It was a mess, under construction. But with what you told me, read that first part to me one more time.
So SMC is under construction and workers have 1,200 feet of fencing to enclose a rectangular space that borders on Pico Boulevard.
Okay, I'll get that rectangular space.
1,200 feet.
And you're telling me this rectangular space, we have it so it borders Pico. And I think I pointed out, since it borders Pico, there's no fencing needed over there.
Yeah, if no fencing is needed for the side along Pico.
Okay,
Yeah.
let's do this then. Let's show that the side is along the street. Therefore, the street itself is going to serve as a border. So I don't have to fence that in, it's already extra border. This is Pico. And how much, material do I have?
So we have 1,200 feet.
1,200 feet of fencing. To do this. Now read a little bit more.
So it says, if no fencing is needed for the side along Pico, what is the largest area that can be enclosed?
Okay, so they want to know how can they use this 1,200 feet of fencing most efficiently and get the most area. That's what they want. They want to know how to split that 1,200 up. Should they split it up evenly? 3, they got 3 sides. So just divide by 3 and call this 400, 400, 400. Would that give the greatest area? It's not going to. So there are other ways to split it up. Well, they may have to make a decision here. We'll make a decision for them. We'll do the math for them. Guys, if you divide by 3, 400, 400, 400, I don't think that's gonna work. Maybe they'll say, well, make this one 200 and this one 200. That's 400. That would leave this one down here to be what, 800? So we have to determine what is best for us to get the most area. How am I gonna fence this in? So I need the length of those sides. That will give me the most area, the maximum. Did they mention maximum? Did I mention maximum?
Maximum.
There's that word, maximum. Area, okay. Guys, since these are unknowns, I don't know whether it's gonna be 400, 400, 400, I don't know. Or 200, 200, 800, I don't know. Plus the possibility is to get 1,200. I want the one that will give me the biggest area. area inside here. Okay, guys, since I don't know what it is, let's call this X and this X. Now, is there some way you would like to, as a student, represent the remaining side? Now, I've got to put something on here. I heard something, Y maybe? You say, can I put another variable? You can, you wish. Now, these two guys are definitely going the same length. That's why I put X on both of them. Down here, this looks like it's longer. That's gonna be a different length, I guess, so it's Y. So it's X, Y, right? Jonathan, with what you gave me, step one, you said all three of those should add up to 1,200.
Yeah.
So let's add them up. I don't know what they are, but here we go. So we've got an X for this side, X for the length of this side, Y for this one. Guys, if I add those up, please tell me, do I have 2X plus Y is equal to that 1,200 that he gave me? Those three sides should add up to 1,200. 2X plus Y. Number two, they're saying, so hold on, we know that. They want you to do this. Now maximize, use this word, maximize the area inside there. Maximize the area. How do you find the area of a rectangle?
Length times width.
About across the street, yeah, of course, length times width, width. About across the street there, and that's one of those, middle school kids, I would hope. They would say, oh, no problem, it's length times width. This is a standard formula for the area of a rectangle, length times width. What would the length times width, the way I have mine labeled, look like here? Y times X. Here's the width, here's the length, just multiply these two together, that's length times width. But mine, in my case, would be the area is equal to the way mine's labeled, X times Y. Or Y times X, you want to turn it around. That's the area. Now, class, the reason I brought this in today, they want you to find the maximum on that. That's the area function. Now, can a student tell me, please, if they're asking me to find the maximum, which they are, they're saying find the maximum area, and I brought right down the area is equal to XY, X times Y. Can anyone tell me, based on before the break, why can I not do it right now? Even though they're saying do it.
It's not a function.
Okay, it's not a function, tell me more, close, very close what I want. Yeah, exactly, it's not a good function. Eric, I'm here to, Eric says, Professor, first, we're accustomed to today, in all math, a function, right, is a of x, like f of x. Well, there's still a problem. Then I heard it's not a who said that? Beautiful. It's not a quadratic. I've been dealing with quadratics all this time. It's not a quadratic. Now, can someone in this clever class tell me, how can I make that turn into a quadratic? And therefore I can turn to something we did before the break and find what they want me to find. It's not a quadratic, I don't see a square in this. Someone be clever, tell me based on what you see on the board, Professor, I think I see it, how I can change that in the red into a quadratic. I'm gonna go for it.
Would we have to write it all in terms of the same variable, and so y and y squared or something like that, or x?
Oh. Trying to follow what you said there.
We use our 2x plus y is equal to 1,200.
Okay, now, okay, it's there for some reason, I haven't used it yet. Eric, what do you have in mind to do with it?
Maybe square both sides.
No, that's getting really, you could, it's gonna take you nowhere. It's gonna take you nowhere, but there's something that's gotta be done there, absolutely, right.
Y equals 1,200 minus 2x.
He says, Professor, go back to this, don't square both sides, you could, but it's not gonna take you anywhere. He said, solve for y, get the y by itself. Just move that 2x over and rewrite it.
And then do you plug that in as y
I
and a is equal to x?
see. Just move the 2x over, which I could. in the blue and substitute it right there for y. Now I have a substitute for y. And if I do, I'm gonna end up with x times, here goes, and guys, put in blue, the y, with the rock's help there, is 1200 subtract 2x. That's what y is equivalent to. That's made a substitution. Now, if I use the distributive property, it looks even better at this point as distribute the x. 1200, oh, look at this, subtract 2x squared.
1200x.
Is that now quadratic?
1200x.
What was it, 1200x? 1200x. Is that now a quadratic?
Yes.
1200x minus 2x squared. I've turned it into a quadratic with his help. And that's what I did all day today. Now I should be able to find, John, I think you said maximum, right?
Yep, maximum.
How do I know this thing has a maximum to begin with?
This is quadratic.
Look at this. How do I know this does or will have a maximum but not a minimum? If you turn this around and rewrite in this order, same function, let's rearrange the terms, is this the A?
That would be a
As this A is negative, it means it opens what?
downward.
Down. If it opens down, are we dealing with a max? And that's what we're asked to find here, find that max. Now what's the quickest way to find the max? You want to complete the square? I don't want to. What's the quick way to find where is that maximum or vertex? Okay, what's the quick way to find it?
Negative
Use
b over 2a.
the formula. Negative b over 2a, or go directly into 4ac minus b squared over 4a. It's up to you. I'm gonna do the whole thing here. I'm gonna use x, right there. Guys, on the side here, you put it up here. X is equal to, here's the formula. I can apply it to my quadratic. Now be careful, this quadratic, it's up here, right here. A negative, b in this case is 1200, do not let me mess up, over 2 times a, and a is negative 2. Let's replace my numbers into b over 2a. Let me step back and look at it, make sure I did that correctly. It looks good. It's gonna be a positive answer. 1200 divided by 4, what is it, 300?
Yeah.
Oh, guess what we just found? Guess what we just found? What's x representing?
The x coordinate of the vertex.
This is 300. This is one way to think of it. This is 300 feet. I found x. But I think you said, Professor, that's great, but they want you to find the maximum what? Area. So I'm not quite finished. What would I do now, as we did before the break, to find the other part which I need?
F of 300.
I could find just f of, I love that area, f of, or a of in this case, or use what, 4ac minus b squared over 4a. It's up to you. I think I'm gonna take Eric's suggestion and find, in this case, it's a of 300. Just plug it in directly, add to my formula, right it is, negative 2 times that, some big numbers here to work with, plus 1200 times 300. Let's get back and make sure I put that 300 in there correctly. Guys, it's awkward as you know what, but that's, Eric, you are correct there. That's what's supposed to happen. I know we can stand here and multiply 300 times 300. I can find that 300 squared. I'm gonna do this if it will help. I'm gonna do a little factor. I can do the math though. I'm gonna factor out a 2 and a 300. You can factor out something else if you wish. Let me see if that will help me. I'll take out 600. If I take out 2 here, they cancel one of these 300, so I'm gonna have a negative 300 left over here. I hope I don't mess it up. Down here, the 300s cancel out completely, and I guess a 600 left here. See if I'm correct. As I took that out of those 2 terms, is that what I would have left over, yes or no? I think it is. A little factor. Or 2 times times 300. Inside there, put those numbers together, it's 300. So it looks like it's gonna be 2 times 300 times 300. Guys, help me out today, Mike, because I know it's a 9. 9 what? What is 300? 3 times 10 squared, 3 times 10 squared, oh, we're getting some big
9,000.
numbers. 3 times 10 to the 4th, what is that? Is it a big number? Or not? Yes or no? I'm doing the math in my head here. I know that could be expressed as 3 times 10 squared.
Said 90,000.
Oh, is it? And then another 3 times 10 squared, that's 9 times 10 to the 4th. Oh my lord, we gonna get a big answer like that? I guess we are. 9 times 10 to the 4th is what I'm visualizing. 9 with what, 4 zeros?
Yes.
Yeah.
Oh,
Yes.
Lord, Anna, why am I doing this? 1, 2, 3, 4, 90,000? Now, when I do this to you on the test, these are big numbers. Multiply it by 2, what is that, 180?
Yeah.
Oh. Jeez. That would be the maximum area that we could fence in with that particular fencing that they gave us. Oh, my Lord. I could do this. Might make it a little bit easier to find the answer, because that, with those big numbers, is awkward. Guys, I could do this. We found x, I think, by using negative b over 2a. And we found x quickly to be 300. So we said this must be 300 because this is x. This is x. Could I go ahead and find the y? Yeah, all three should add to what, 1,200?
Yep.
So we got 300, 300, that's 600. Is this 600 then? Does it have to be 600 down there? Is that 1,200 now? Now, if you find the area, length times width from across the street with the middle school, they'd say, oh, you don't have to go through all that, Julia, professor. Just multiply these two together, length times width. I bet 300 times 600 would give me that same answer. You multiply those together, length times width is area. Rather than me going through all that 4ac minus b squared, or what I did, or I plug it in directly to find the answer. Guys, this is a big number, awkward number to work with. Does it make sense though to find the maximum area?
Yeah.
Wow. Whew. Now, I gotta take a breath, you gotta take a breath. We're closing down. I have one more handout. I'm watching my time here. We're supposed to have a little short quiz today. Oh my goodness. FedEx was ready for me today. Picked my copies up and all, they smiled at me this morning. I think that's ready for you. This would be closing down, chapter 2. I'm gonna go do it right now, guys. Jonathan, tell the class, I'm gonna pass this out here. What does it say on the back of this when we finally get it? Section 1.
3.1.
Well, I'll be in chapter 3 tomorrow. I think what I'm gonna do, since I do want a perfect score from everyone on this little quiz tonight, and I want everyone to get the little extra 3 points. I think we'll stop now. Give you the remaining time right now to do that quiz. You have plenty of time to do it.